Hi everyone. Today, changing the reference half cell. The table of reduction half reactions and their electrical potential in the data booklet is set up with 0 for hydrogen. Hydrogen is the reference half cell for this table in the data booklet. Questions are sometimes going to ask us, what if the reference half cell was changed to something else? And so a few things just to note. Any half reaction higher up on the table than the reference half cell is going to have a positive value. Anything below the reference half cell on the table is going to be negative. That's the first thing. The second thing is the relative distances in between one line to the next are constant. For example, the silver line is at 0.80, and right below it is iron 3 getting oxidized into iron 2. The difference there is 0.03. That difference in between there is always going to hold stable. But we can shift all of these numbers around by changing the reference half cell. So here's an example. If the reference half cell was changed to a lead-2 half cell, what would be the reduction potential for hydrogen, silver, and cadmium? This is saying, keeping the distance between all of these numbers intact, what if instead of hydrogen being 0 on the table, what if 0 was the lead-2 half cell? I'm going to find that line. The lead-2 half cell is right here. It's the line right below the hydrogen. So if that was 0, what's the new potential for hydrogen? It can't be 0 anymore. Hydrogen is the line right above the lead-2. Because it's higher than the new reference, it's going to be a positive value. And how much higher is it? When I'm looking at it, it says hydrogen is 0 and below 0.13 is this new one. So to go up to the hydrogen, I have to go up, so it's positive the same amount, 0.13 volts. Silver on the table here is at 0.80. It's higher than this new reference, so it's going to have a positive value as well. How far up is it? From 0.13 all the way up to 0.8. We have to go up, 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 up. You need to look that up in the data booklet yourself. Find that at 0.93 volts. The distance apart from the silver line down to our new reference is 0.93 volts. How about cadmium? Cadmium is here at negative 0.4. It's below my new reference half cell. It's going to have a negative number. Okay. But how far down do we have to go from the new reference half cell until we get to the line that we want? This line is at negative 0.13, which we're going to call 0. How much further do we have to go down to get to 0.40? .27 volts. It is an important style of question, changing the reference half cell. It's sort of saying, what if the numbers in the data booklet were all shuffled around and the 0 is at a different spot? What kind of new reduction potential, what numbers would we get if we changed where the 0 is? Anything higher than the reference is positive, anything below the reference is negative, and the relative distances from one line to the next are intact. Because the relative distances are consistent, by changing the reference half cell, we are only going to affect the reduction potentials. Changing the reference half cell does not affect the overall voltage produced by a voltaic cell. And I hope that helps.